There, welcome back. It's me, and I realized after listening to the last video I made that it sounded very, very quiet, and I checked, and somehow my microphone volume turned way down. I don't remember doing it, but I must have turned it down for some reason. And now I've turned it up again. Hopefully it'll come out right this time. Also, I remember last video I said that some seconds had been cut out. I noticed that some seconds had been cut out from the video, correct? Well, that some seconds was actually more like an entire minute. 58 seconds missing. I was talking for 58 seconds while that file was being loaded up in a hex edit program. So that means just F3, a single call from, I should add, and that matters. I probably have the code in here still. Hex edit. No. Here, I think. Here, you see? Number of bytes, here's the buffer, number of bytes to read, 1. So that's a call that if it faithfully carried that call out, then it's true that nothing would have, no sound would have been able to get recorded during that period of time, because the bus would have been too busy for the entire duration of the transfer. Normally things are split up. Oh, the bus. The bus is the part of your main board on the computer where communication between the various devices connected to the main board or on the main board has to pass through. So from hard disk to memory, if you want to transfer from hard disk to the RAM memory, it's got to go on the bus. Okay, it's a pretty good analogy. Now, if that's a single call to transfer that many bytes of data, I can't imagine that would be how it would implement it. And I don't know how like int13 is the DOS. Is the DOS interrupt? I wonder what the parameters are. Just curious. It might be that you can specify a large number, and that it would be a blocking call. These are the disk read and disk write, not DOS, but BIOS function. This is still valid, by the way, on your computer before the jump into hyperspace. So as you first turn on your computer, this is these are the services that are available to the Bootstrap loader. So read sectors into memory would be something like this. Number of sectors to read must be non-zero. Low 8 bits of cylinder number. So when it's a hard drive, You have cylinders and sector number and head and drive. Anyway, there's a specification, a way to address the smallest bit of data on a disk. It's what they call sector. In RAM, the smallest unit of space or data is not called a sector. It's called a page. Called page. Now, so you put into A high 2. You put into A low the number of sectors to read it. You tell it where from, and then you provide a data buffer, and that's it. And then by the time the function returns, it either succeeded or didn't succeed. But now there's another thing called, I've mentioned this before actually. What's it called now? It's I/O completion port. That's the word, phrase I couldn't remember. That's the method of performing asynchronous I/O, hardware communication distributed amongst multiple threads in the same process, without locking the bus. Okay, and it's actually described in this little article here. This method of transferring data is called overlapped I/O. Okay, and if you've ever called this function, that's the first thing that you do is you put null. Everyone puts a null here because it's very complicated. But if you do it, if you do this, use this mechanism, then you won't have the problem that I had of losing 58 seconds sound. Okay, and I'm sure that this program doesn't. Neither does this program use what they call I/O completion ports. It's like a signal. In fact, I think you just specify a function, and your function gets called when the thing is done. Anyway, we'll look at that some other day and actually try it. See you. Or back to the video. Is it in here? Must be. Okay, now XML. Now remember I told you that file, this file here. Yeah, log. What this log file is something generated by process monitor, the system internals program. I'll generate another log file. It won't be so big. I wish I could figure out how to do that. You see, there's this program called FreeMake, and it takes forever to start. And I was trying to see if I could, I'll just take a trace of everything it does during the process of its starting up, which is a long time, and then save that to file, and maybe I can figure something out. Well, I didn't realize, but it says this program can save to an XML file, and I have my XML reader, and so that would be very convenient, a very convenient way to organize the data, and I've got a search feature and everything. But let's not use that process. How about notepad cube or something? Process name is and include. Now start this, I might as well. And then I just say start. Are there any running? No. And nothing should get through initially. Everything's being excluded. So now if I run my notepad cube, I should see something. Okay. Now I can say stop. It should stop. Hopefully my voice is getting through. It might help. Doesn't matter. Okay. Now that's quite a bit, but only at 1,300. So I click on this save, and I saw, oh, XML. Okay, I'll use that. Events to be events displayed using current filter, right? Okay. Profiling events. I could have left that out. I could leave it out, but I'll leave it in since this one's not too big. And I also wanted this. Will increase size. Well, I wasn't worried about that. This is useless because I don't have the symbol files. So I'll call it log file like that. See how big it is. Okay, only 7 megs. Now I've never seen one of these actually. So if it works, oh, I can use the one that's in my. I can use the old version. And I'll try the new one after. Now you won't see it until it I think completely parses the file. I think it does make a console, but there's not much left to see at that point. In the meantime, yeah, so there's that asynchronous IO, and let's see what I want to do. XML view. So I tried running my XML viewer on that log file, and I'm waiting and waiting and waiting, and the spinner never even started going. You know how I have that spinner? It's gone here, but I put it back, and so then I went to try and find out why the spinner didn't even get going. And realized, oh my god, the file is huge. But anyway, so I added more calls back to the spinner and saw that it was spinning and spinning and spinning. But I figured it'll take a while, so I just let it run in the background, right? Well then, eventually I get a crash, you know. I was running it into the debug version. Assertion failed. I could do it, you know, I could get an old version to show you. The assertion was maybe know the line still, I'm sure. Plus operator plus equals TS string. What else, right? Where all the allocating occurs. Now I never expect an allocation to ever fail, right? this here used to be a void function. I figured I'm never going to be allocating so much memory that I'm going to use up every last bit of memory in the system. That's impossible, right? But it did. I used up every last bit of memory in the system. The programmed image in task view, task list, had it having an image size of well over 1 gigabyte in size. No, it's really not coming up with that. Is it running? Oh, here it is. Now where's my tree? Now it's going to build a tree. But it doesn't do the spinner. Like in dialogue init, WM init dialog. Oh, here it is. No. Thought it had a console. And you can see that it's working hard. Right? Oh, it's not working that hard. Just wondering where that CPU usage thing works. Well, something's using up a lot of CPU. Oh, of course, the recorder. When it says 50%, I learned the other day, that means 100%. Oh, I've also got virtual dev doing an encoding. So actually, I could later. Well, no, it should be okay. Well, that's curious. I guess because what it's doing now is it's building a tree control, and that involves calling system functions. And whenever you call a system function, that allows the system to give resources to other processes. If it was just in a loop doing nothing, then process usage would go up to 100%. This means 100%. Apparently, on a 2-processor system, if it says 25 on a 4-processor system, then that means 100%. Apparently, the way that usage number is computed is such that the actual usage is that number times number of processors. Well, it's approximate, right? Because this adds up to more than 50. But anyway. So it wouldn't load up. I never got to this point. And then that was when I tried, that's when I got back into my hex edit, and I knew that I could open it with the hex edit thing. I did, but it took a while. And then I told you about Notepad Cube crashing. Now, where am I going with this story? Okay, so the realloc was failing, and I went to look at this code. I should get an old version, so just so you can see what the hell that I went through in trying to get this thing to just run without crashing. It still never loaded it up, right? It will if I leave it long enough. Let's see, I can get an old one. Say here. Now the way this XML lived, I'm using a third-party library, right, that I compiled myself. And it's a very simple thing, the XML library thing that I use directly in here. Yeah, these are just regular C functions, okay? Not even C++. Parser is like a p void type thing. It's declared in a class, I guess. Okay, node is an internal thing. Another case where see, here's our Uncle Outer again. Parser is parser. And passed in. So we're looking. What was I just looking at parser? Oh, it's declared right here. Parser is just, you don't know what it is. This is a type of handle value, right? But you call this function, it returns you a thing, which you then, in the C world, you pass that thing back in order to do something with it. So in a sense, just like with COM or any of these types of things, you ask some service to create for you some kind of handle type, which you then use in order to perform operations that you'd like to perform by passing that handle back in and specifying some kind of function, right? Or just calling the function that you know. This here is exactly the way a COM call is made, right? This pointer, as far as the compiler is concerned, this pointer is the first parameter in the argument list. So there's, if I pretended that this was derived from I unknown and compiled this, then I would be able to write. I would be able to write this down, right? And believe it or not, if that's a standard call function, that would succeed, because all the compiler does, oh well, it adds 8 or something to this maybe. But all the compiler does is put that argument on the stack for you. In any event, once you got the parser, you're allowed to set, just like with Windows, right? When you create a window, you want to have some user data that you use when you get called back on, right? And this pointer typically, and that's what this does. Now, element handler, this is like WinMain, okay? He could have designed it with just one function that gets called back with different messages. That's one way to do it. Another way is to do it the way he's done it, which is instead of messages, a message is a function gets called back. Okay. So if you look at the declaration for this, it's your parser, and then this type of handler, and this type of handler, an element start handler, and an element end handler. So as the parsing is going on, when an element is discovered and parsing of that element begins, this function gets called back. Okay, and then that's these brackets, the beginning and ending of a parse of a single element, and this callback is called when data is read pertaining to that element. Fair enough? So you'll see this first, then maybe a bunch of these, and then this. So that's nicely bracketed. Calling this function XML parse actually starts the parsing going. So now this const char star is the data that is the actual file. You know, like the XML file's string data, and the length of that data. And this is a Boolean. I shouldn't put true here, but whatever. Is final. I'm not sure what that is, but oh, I see. I guess you can do it in parts. You know what I mean? Like what this is telling it is that that this string completes the whole string, the whole file's data. I could have done this in steps, maybe, you know, done part of it and then resume later on, and then done another part. And on the last block, I would have to say now it's complete, and then it'll make a check that it truly is properly completed. So at this line, the parsing's done. So where did all the, you know, where's all the work? All the work is in these callbacks. So that all the work is done. Well, the callback gets called. Oh, well, that's in here. Okay. Now, remember, there are three callbacks: start, end, and data. So this is neither of them, right? Neither is this, because this is a member function. Right? Well, you can't tell that it's a member function, but there would have to be an arrow before this m underscore, for me anyway. With my naming convention, if m underscore means member, so this is a member function. So is this, and so is this, but they have the same name. And the callbacks themselves like this is declared as a XML start handler. Not that. That right? I'm just trying to get to his declaration. Okay. Something start handler. Here there was an underscore. Start. No. Oh, no, what was it? This function takes and start element. Okay. So this is the type of callback function that is a start element handler. And for all of these things, the first thing that gets passed is your user data. So that allows you then to take this as a this pointer and turn those non-member function calls into member calls by simply flipping those around, which is what I have in here. These are the non-member ones, right? And I take the first thing passed in, cast it as a pointer to my type, and then call the member functions. Simple as that. So now you have a nice thing that A tells you the name, that's like the name of a node. Still not done. And these here attributes are in an XML file. Okay, easier to see with this kind of editor. Okay, you see this, well, this is like the head node of everything. It's like the meta tag sort of. But once you get past that, what are these dots? Are they actually dots? 3F, 3E, not exactly. There's a carriage return. Oh, that's a carriage return line feed. They're not required, but you can put them in. This says procmon proc list process, right? Now, whenever there's a open brace and then a symbol name and then a closed brace, there will have to be, just like with HTML, a corresponding thing that has a slash in front. Like if I look for this procmon, we should find one, a slash procmon somewhere down here. Procmon, we don't have a search feature. Process ID, process list, process. This here stuff is what they call the data. Okay, here's one that's completed here. Parent process ID, and then slash parent process ID. So this here is a complete XML element. So when the parser runs into this thing, it calls the start element handler when it sees this bit with this as the name, and attributes are none because there are no attributes to this element. Attributes appear within the angle brackets along with the name. There's the name, followed by any kind of white space, and anything following that white space are called parameters. Doesn't matter what the format is. I don't know. It could be, in fact, this procmon should be, the close for this procmon should be right at the bottom. Am I really at the bottom? I don't believe I am. That it would end exactly on that. It's not at the bottom. I have a bug, of course. Anyway, event list, process. Maybe I'll get it by accident. It's so huge. See, it's not the same as it's my phone. Okay, notepad, we'll open that one. And it's got carriage return line feeds, fortunately. I gotta fix that bug. Yeah, I keep getting that bug because of the scrolling. I'm always getting off by one. I'm sure there was only one more line. 16 bytes more. That's only 7 meg. How's this guy doing? Still not these response? Oh, it is. Well, something, it just didn't work. Okay, it failed. Not sure why. There's nothing wrong with this file. And you said, well, you didn't see, but in fact it does. It is. Yeah, there it is. See? It is going through and parsing these things. I know because I saw it happen under the debug. A great big tree structure with all these nodes. Why it didn't work? Not sure, because that version is known to be working version, right? It works with, I think it is. Special one, set something. If this doesn't work, I guess it's a problem with this thing. You're right. You see how I'm wasting. It's not a waste of time, though. I meant to talk about not only the memory thing, why I wanted to be able to use this XML viewer, how I ended up in that situation, and how paying attention to memory usage might be very important. And one thing I can show my client to demonstrate if this ever starts out is I believe I've come up with a compression algorithm for XML files that will reduce that 800 meg file to less than 2 meg, less than that even. It should reduce it to something like on the order of maybe 100 kilobytes. It's a great compression algorithm. Oh, come on, why aren't you starting up? We should use the new one. But you can see that there's nothing. Oh, I mean, no, it's not the same file. You can see that there's nothing to XML. Let's open and close, open and close, open and close, and eventually stop. The code that calls these callbacks is not that complicated, is what I'm saying. And using these callbacks is also similarly not complicated, provided you're not worried about memory. Once you start to worry about how much memory you're using and have to become careful, then you also have to become a little bit clever. I'm trying to get to that cleverness. I could pause this. No, actually, I'm going to pause, not only pause this one, I'm going to stop this one and save it off and start a new one going, just in case I've lost the audio. Okay, let's see what I did was the file that it produces is always called out, and so I just moved it away and it won't get, now I'm making a new one. So I'll be able to check this and see if it's messed up like the last time. And in the meantime, this did complete, and here are all the entries. If I look at that one under notepad, you can see how that translates. Okay, now it turns out this happens to be all just one single line. First, I'm just going to check to see if it really, okay, now see this says ANSI, however the encoding is not ANSI, it's UTF-8, and you might see weirdo characters in here because this doesn't have the byte order marker for notepad. You'll see them in the viewer, but not in here. If there are any non-ANSI characters, they won't display in notepad because XML doesn't use byte or byte sequences. It uses a meta tag like this. The version of the XML library or XML spec is 1. The encoding is UTF-8. It's always UTF-8. So the first node is called URL set, and these are just parameters. The meaning of the parameter is understood by the person who designed this XML file. There's no special meaning that you would attach to these things. So I just display the parameters here. Although there is a format for parameters. It's parameter name equals value, and any number of times over and over again. You could have 10 parameters, and the name of the parameter and the parameter value is separated by an equal sign. I'm not sure what, no, if that's fine, you can still have an equals in the parameter, right? It's name, then equal sign, and then whatever afterwards, which could include an equal sign. There's no confusion about that. Now it turns out, you see, in this case, all of these things, and it's true for the one that didn't load up, there are really only about 6 node names, right, in the whole file. Just the names of the nodes. It might go down and down and down forever, but it's always the same ones, right? In this case, there are exactly 1, 2, 3, 4, 5, 6. There are 6 possible node names. And in this old version, when I would get a node start, okay, I'm maintaining as the parse is going on, like current path, right? Now, when a node starts, that means that the element name is like a new directory. So then I would compute the new current path, which is to add a slash and then the node name, right, to the current path. Then I would give the new node, string representing its path for every node. Well, that alone runs you right up to the 7 FFs, and the program crashes, right? Because there are, hundreds of millions of nodes, right? But they all have the same name. So I was trying to think, like, how can I automate the process of caching these names so that I don't, first off, I don't need to store the whole path even at all, right? You can compute your path because all of these nodes, if you look at the definition, they have parents and children and siblings, right? So if you want to know an element's path, I turned it into a function. Where is it now? Attribute, find, try again here. Oh, here, get path. Okay, pause is the user passes this in. They don't know what the structure is, but it doesn't matter. This is another handle type thing. But I know that it's one of my nodes, and each node has a name. It has a parent pointer, what I call firstborn pointer, and a next sibling pointer. Okay, so those are the only members, and that's all you need for an XML tree, because if a node has a sibling, then the sibling will either have a sibling as well or not. So you can go through all the siblings in one. It's unidirectional, but it doesn't matter. Go through all the siblings by starting with your sibling and your sibling's sibling and so on. And then to go to all of your children, right? You don't need to have a list of children. You only need a pointer to your first child, and then all of your children are the siblings of the first child. See? So that accounts for everything. Now, in order to solve the crashing and automatically build a cache as the file's loading up, a cache of names. I was doing it originally for the names and the data, but it turns out the data is not repetitious enough to really warrant a cache. I'm still doing it. Okay, I don't need this. This could be. It doesn't hurt. The data consists of possibly many strings, right? But I don't want to store. It turns out I decided I don't want to store any strings in this structure at all. Right? They're going to be in a global database of strings that these things will feed off of. So except for the attributes, when there wasn't enough savings in attributes, I could do attributes as well. Doesn't matter. For any string, I just use this same method. Declared in here are what I call databases, and the databases are lists of strings. Okay, this is the database that contains the list of node names ever discovered, and this is the list of strings containing the data parts that have been seen at any given time. Now, in order to retrieve or save and retrieve something particular to a given node, it simply needs to know the positions in the database where its name or data or whatever are located. So instead of having a string, I have a list position called position for, this is where in the name database to find my name. Now for the data, which might be many strings, I have a list of positions instead of a one string with carriage returns. It's best to do it this way because you'll get higher compression that way. If there are many occurrences of a certain format of data, let's say separated by carriage returns, maybe like a property of a file or something, then taking that entire string and putting that in a database is probably not going to come up with many matches in the future, right? But if you broke it up into its lines, almost certainly you're going to get some. You're going to save some space, right? If it was the properties of a file, right? It might say date and then some dates, right? Well, most of the files on your system all have the same date, turns out, right? Everything under the Windows System 232 directory has the same date. So why would you want to save that 1 trillion times for every node? Windows. Yes, but you don't have to think about it. You just keep adding things to the database. All right, now this is just it's system 32. Okay, see, these are all the same. These are all the same. Okay, and then you're going to find these, probably the same information for these same files stored over and over again. And so instead of the program using up, it crashed at a gigabyte. Instead of using up a gig of memory, it never gets over like its initial program image size. Almost instantly, you stop getting new names, right? I could run this. I know this is long, but it's kind of fun, don't you think? Where's the XML here? On that crazy huge file. Then it should be debug unit code. Yes. No. Yes. No. No. Yes. And you'll see that I'll put a breakpoint where the elements are set, and you'll see that it'll go there a few times, and that's it. Previously, for every single node, I would allocate a string to store that same data, the same name. If it's a long name, Imagine how much space is wasted. And then I was storing the entire path for each thing, right? Even though all of them are permutations of the same strings now in my database, right? A path, all of those paths are simply permutations of the elements in this list, or this list, I should say, rather. I thought I took away the data one. I guess it was the attributes I took away. So there's nothing to the implementation. But after doing this, it stopped crashing. Try to find the string passed in. They happen to be not Unicode strings. They never are. So I have to create if this is being built as a Unicode build, and I'm using TS strings, then I have to cast these up to wide characters. That's okay, no problem. If it's not found, then I add it to the list and return the tail position. Okay. Otherwise, if it is found, right? So one node hits this thing, and it ends up in the database, and it gets returned to that position at the end. Another thing comes in here and tries to find, a given name, the name of its node, in the database, and finds it and doesn't have to allocate a new TS string. So what am I using for my file? I'll stop after this. Now, what did I just do? What did I do? Add it back. I wanted properties. This one. Just see what file. Okay, it's currently set to the great huge thing. Maybe I should set it to the one notepad cube instead. But well, okay, I'll do this one first. It won't finish, so I'll just show you that its memory image gets to a certain size and stops growing. And I'll just show you this working. I run the program. And it has that path as its parameter. I don't want that there. Okay, coming here almost right off. So this is in the constructor for the object itself. Oh, right. I give the where is that here? I'm creating a tree, a node basically, and I give it the name root. Okay. There's a chance something else might be called root. It's case sensitive too, right? I could make it case insensitive and maybe even get the compression down even better. But anyway, let's try to get something real here. Element start. So at element start, in this case, procmon. I'm looking for where in the database to find my name. This is my name, but I don't want to store this. I just want to store the database position. So all this puts me here, and now I'm going to do a search. Didn't find it. So add it to the database and return the tail position. That's where it was added, and then we're done. Oops. Right. Okay, process list. That's going to fail. Okay. All of these are going to fail for a while. Process index 1, process ID. Oh, these are data. You see, now one's going to come up again, right? So it really does. It helps to. I don't think we saw that yet. It helps even for the data part. 3012. Who knows? Maybe I'll see that number again. It's not a big number. Process index. See that yet? Yeah. 2. I'm pretty sure we'll see 2. Okay, now what I'd like to do is put the breakpoint here instead, so that we only get jump there when we're adding things. See, it's starting to slow. It's starting to actually do some work on it, but it's the data things that are going to get me in here, I think. Okay. You see, it's not instant anymore. That whole sequence was in processor time, didn't find any match. And again, well, I let it run. It's always going to find something new in the data section, unfortunately. So it would be better to split it up and have two similar functions, just so you can see that the names database is full. Okay, this is LM data. If you see LM name here, you'd be very, very lucky. I don't think we'll ever see LM name. Sorry, start or end or anything in this call stack ever again. Well, how big is this names database? I won't show it. Okay, I have to force. Oops. I can't see this thing. Why won't it show me? Maybe this thing will do it. It's sometimes it can't give you global variables. Okay, 28. All right. Now there are thousands and thousands and millions of nodes, right? But there are only 28 names total for 28 possible paths in the entire tree. So by doing this, I don't know why I got 2 of these. Oh, that's this thing, right? That one only had 6. You see? This was previously a gigabyte, right? Now that file, this number doesn't grow. And that file when it finally, if it ever does get loaded, right, will have been stored in that tree, which is only some hundreds of kilobytes. The program itself is base images. The minimum is that, so 200K. So you can take an 800 meg XML file and using that caching algorithm, compress it down to about 200K, because all you would do is open it using this thing, and then to save it compressed, you write down the strings in these databases first, just as strings, and then a sequence of numbers that correspond to these strings, right? Like you could do it in binary if you wanted to use a single byte. For open bracket, you could use like the number 1, or the first bit of a byte, and then, well, depending on the size of these things, you could certainly fit an entire node into a D word, right? The number, sequence of numbers for the strings, and everything just refers to the dictionary that you printed out first, and the offsets. You don't need to say pointer; those are pointers. The indices, each of these has an index you could figure out when you save it. So you would have you could write a thing that I bet would beat every compression program in the market for specifically for XML files only. I'm sure that a lot of other files that are filled with redundancy are like that. Look, it's up to 1K. Anyway, I won't finish it. I could try the other file. One thing I forgot here. In this program, I added a sleep here too, so that it wouldn't use up all processor time. But I could take that away. You might lose my voice, but this will be the last thing I do, and then I'm done. I'm curious to see if it can open the other one, but the previous version could not. Here. 10. Just add notepad key. Right? Take away the sleep. I could put sleep 5 or something. Anything to give time back to the system, and that shouldn't affect the load time too much. It will affect it, but as fast as possible. This means that it'll bring it up. The usage will go up to the 50. It'll be in competition with media encoder. Speaking of which, I'll pause. Okay, well, it started. I could put a breakpoint and see how many notes we've got so far. The CPU usage will be high, but the memory footprint won't be high. 15. Right. So it's actually done a lot more work in this short period of time than the other one did. But that's nothing compared to this. The file is 7 gigs. Right? gigs, yeah. No, meg, 7 meg. Still a lot. Yeah, right. 2 gigs is the limit as far as memory goes for anything. Well, not everything. Things that don't load entire things into memory, like MS Dev or something like an archive program, will need to be able to reference offsets certainly larger than 2 gigs, right? Or a thing that plays a movie files are typically nowadays 8, 9 gigs. Okay, I'm gonna stop this and hope that it completes its thing, and I'll let you know either way. And this part interesting. This here actually no, it's supposed to clear to the end of the line. No, it's clearing to the line. But if it's building the Windows tree control, I have it print out the node name as it's doing that. That would be init dialog. Here, I get to before it's finished. It's still going, so I can put a breakpoint. Not there. Here. Okay. Every time I'm adding actually I'm creating 2 things. I'm creating a Windows tree control, and I'm creating a map of these handles to something, to the path. Oh no, to the data. Sorry. So if I shouldn't really do it for ones that don't have data, because it actually costs money to do that. But anyway, whoops. This thing I'm doing myself, I have the control, and I'm walking with it through the walk function, right? Very much like a list. Get first ones, like get first position, and then there's like a get next type thing, right? But get next really is the same as get first. And then get sibling, yeah, that's it. So you go through the sibling, and for each sibling, you traverse the siblings, right? Pause is the current position, current group, and this here is the Windows H tree thing associated with that, associated with that root. We know that this will at least work with that other file. I don't know what's going to happen with this. Okay, and there it is. Completed that task. Block man, process loop, and event loop. Same. Here again, I create event, create finish time,
Now, this is the way I like to read something, right? It's all nicely organized. This is that this came from process monitor. Here are a list of events that occurred. Here, here's the stack frame. Address, path, location, right? It's telling me, it's giving me a stack trace for an event or a given process. Process 67. I imagine these are numbers from index. First thing, 1, 2, okay. So 67. That's under the last one. It is. Command line. Notepad Q. Okay. So you see how that's interesting. And here are all the modules that were loaded at the time when this snapshot of this traces table loaded into the address space of that program. And here's the version number of this particular module that was loaded. Oh, you can't hear me, my microphone. But you saw what I was just doing, showing you how everything, it worked, right? This could never have succeeded with the previous code. Right? I would have run out of memory. What's the program image in memory? Remember, I had to allocate all of this stuff too, which I could probably fix. And that's where all the memory usage was done, right? So it wasn't long after when it switched to this part. So therefore, I now have a way to compress an XML file to almost nothing, right? Just a few bytes, and in a very easy way. You just read it in, and then write out the lists of strings, and then walk through all the nodes, and each node can be represented as a series of digits, right? The indices of the no strings, right? This tree, for instance, this node would be represented as the data in the node structure, which has its name, its data, and that's it. The name and the data, and its path, which you can work out by function, right? Like as you're building your output, its path can be represented as a string of digits because each of these names is located in one of those databases, right? So if the maximum depth is 10, let's say, that would be 10 digits. But for the names you saw, there were only 28 entries. So I don't need to use a whole D word. I only need, how many bits is that? 24, 5 bits. 5 bits is enough to specify one of these names. And so the path can be, if the maximum is 8 or something, 8 times 5, 40 bits. A 40-bit digit represents the complete path specifier for the node.
And the node data also is represented as an index into those tables of strings, the dictionaries. And so there you go. You want to make $1 million, there you go. I want to make $1 million. I wouldn't have any way to for anyone to even send me any money. All right. Well, I hope you enjoyed that. I'm glad that I've actually seen one of these open up. Now I want to open up that FreeMake thing. Although, this is a pretty nice view, but it's not perfect. There is the search though, like I don't know, who can I search for? I suppose I want to search for ntuser.dat or something. Should find that. That's the registry. Oh, maybe not. It may not show up like that. It could. Is that active? It is. It didn't find it. Okay, let's find something else. Shell 32. Okay. So the search feature works fine. It's case instance. It took me, like I said, minutes to write this program. I haven't done much. And I only search in the data part. Like regedit, you know. That's probably about as long as it took them to write that program. How about, what's something bad? That might have got into my program. Hook. Anyone knows the word hook? Like that M hook? No. I think it's finished. Yeah, it's done. I don't print a message saying it's done. It should. What else did I search for? What would happen with the process? Oh, let's say HT local machine. Well, that's probably not how they would write it in this trace. How about HKR? Okay. So that works. That's how they write down registry things. Okay, I mean, maybe I might want to search for this thing. I think it definitely starts from the top. Okay, it's finding it. I don't have a search. It just walks, and there, okay. This does actually tell me on at the end. I see. What's another thing to search for? Here, what about this? Like, what's this thing? I'm going to have a lot of fun now. Finding out what happens when a program starts up. And now I have to make this a really fancy program. Now I've added a new thing to my